Professor Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in Electrical Engineering at the Institution of Engineers, India, Calcutta, and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites, and insulation technology. He has in-depth experience on plastic properties, testing methods, and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers, and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in polymer science. In polymer science, we have been discussing about polymer rheology. That is the course we have been discussing so far. In polymer rheology, in the last class, we have discussed about the mixing process and then how additives are added to a polymeric material that will result in a good properties. In today's class, we will continue with additives. Some of the protective additives we will continue with discussing about that, and then we will move on to master batch. What is a master batch? And then we will look one processing operation, which is calendaring. In the additives, in the last class we have discussed about heat stabilizer and then antioxidants. The next protective additive is anti-ozonants. These anti-ozonants are a type of specialized antioxidant that are used especially in rubbers. Example, unsaturated double bonds in rubber molecules are very susceptible to attack by ozone. So, therefore, anti-ozonant is an important additive in the rubber industry, particularly for tires. Next one is the UV stabilizer. This will often work in conjunction with antioxidant. Starting an oxidation reaction, attack at the reactive site on the polymer by UV radiation, particularly in sunlight. That is this anti-ozonant. If you fail to add an anti-ozonant, then that will become a cumulative effect. Once oxidation takes place, now the material is more susceptible to UV light. What happens when a UV light penetrates to the matrix of the material means it will try to reduce the mechanical properties. And the next important protective additive is lubricants. Lubricants are a processing aid that are mainly used as a processing aid, which means which will actually widen the processing window. Now, a process engineer will have more choices to process with respect to a given type of polymer. These are the functions of these lubricants. Mainly it will reduce the heat that is generated due to shear, because in a extruder barrel or in injection molding you have a screw that rotates at a very high speed, and then the melt is sheared in between the space between the outside barrel and the screw. Therefore, that will result in friction and generation of heat. Now, if you add the lubricant, that will actually reduce the heat, that will eventually help in a good processing conditions. Now, not only that, because of that this will also aids in flow, because once the viscosity will come down if you add a lubricant. Now, next aids in release from molds and machine parts. Not only during process, once the melt once the mold collects the melts and then it solidifies, then this has to be released, and also it gives a glossy surface finish to the final product, and it aids in the dispersion of pigments and fillers as well. Now, there are two main types of lubricants. One is internal lubricant, which is mostly soluble. These are mainly added to reduce the viscosity reduction, thereby lubricating the nodes of the macromolecules. So, macromolecules are nothing but polymeric materials. Now, next one is the reduction of heat dissipation. High shear rates convert the mechanical energy into heat energy. So, therefore, this will actually result in poor mechanical efficiency. Most of the shear rates are converted into mechanical energy and it is lost. Then that will eventually reduce the converting efficiency starting from raw material to the final product. Therefore, the heat dissipation has to be reduced. And then the next type is the external lubricants. The external lubricants mainly act in three ways. The one way is the release effect, that is, it prevents hot melt from sticking to hot metal components. So it will remove the stickiness of the melt whether with respect to the barrel or with respect to the mold. And the next one is the plastification or the retarding effect, that is, it will reduce friction between melt and barrel, wall or the screw. So in either case, and then prevention of melt fracture. Melt fracture is a type of molding defect. The type of molding defect that is usually observed in injection molding process, that is, the surface of the melt will have ununiform configuration. That is what we mean by melt fracture. That is, rhythmic alteration of adhesion or slippage through the flow channel, that has to be prevented. That is where we add external lubricant. Now, looking into the specific types of lubricants, the first one is metal stearates. Metal stearates are added as a lubricant. For internal type, PVC is a good example. For external type, polyethylene is a good example. And then paraffin waxes will act as a external lubricant. Normally, you could see paraffin wax is coated over the surface of the mold, or in the hand lay process, both in the top and bottom plate, people will tend to apply this paraffin wax only to facilitate the release of the composite in the hand lay process, or release of the product from the mold. And fatty acids do have the same effect, is typically used as an external lubricant. Esters can be used as both external as well as internal lubricant, and similarly fatty alcohols do have act as both external as well as internal lubricant. And amines are mainly used as an external lubricant, mainly for mold release purpose. The product, once the product solidifies inside the mold, it has to be released out. Now, we will see how these lubricants actually enhances the process window, that is, the choices that is available for a process engineer. The first one is the mold release effect. This will actually, mold release effect actually have a direct effect on the cycle time. So, cycle time is the total time taken for the melt to fill the mold completely, and as well once the product is formed, it has to be ejected out from the mold. So, that cycle time will be reduced by adding a good lubricant that will give a good mold release effect. That is, this is how it functions. It will reduce the demolding force and a possible reduction in cure times or the cycle time. And the next one is the slip effect, that is, try to reduce the friction, lower friction surfaces. Anti-blocking and anti-slip effect, this takes place inside the extruder barrel, where the melt tends to try to block the movement of the melt towards the mold. That is, what happens is, it will roughen a surface when a smooth surface can cause problems, which is usually in the case of a vacuum state. And also water repellency, it will repel water. And the binding capacity of the binding capacity do what is the optimum binding capacity required for a melt to bind through the screw. Next important protective additive is the anti-static agents, which actually prevent the buildup of undesirable static charges. The same properties that give plastics excellent electrical properties also make them highly susceptible to static charge. So, nowadays people do expect conductive applications from polymers. So, therefore, while you make a polymer conducting, at the same time it also makes the system to accumulation of static charges on its surface. Hence, what happens is, this will attract dust. When you have a static charges on the surface of a product, then it because of the electromagnetic or electrostatic attraction between the dust particles and the static charge on the surface, therefore, dusts are more frequently collected on the surface of the product. This may result in a hygienic problems when it is used in hygienic applications like in hospitals. And then it can also cause processing problems, especially with films. When the films are processed, and these static charges do result in a processing problem, and a static discharge can damage some of the products, for example, microchips. Sometimes the product itself would get completely damaged because of this buildup of the static charges and simultaneous discharge of these static charges on the integrated circuits. Next, static discharge can cause fires that is sometimes it may also result in flammable environment due to accumulation of these static charges. Now, the anti-static agents are added to prevent this buildup of static charges. The mechanism to prevent static charges these are the mechanisms. One way is to surface application of an external anti-static agent on the product, or incorporation of an internal anti-static agent which will help the material to be internally building up of the charges. And the next one is the incorporation of conductive additives to dissipate the charge. Sometimes you also add a conductive additive that will help in dissipating the charge. Whatever the static charge that is being accumulated, now a conductive path will be established by these additives. So, thereby preventing the accumulation of the static charges. Next we will move on to master batches. What is a master batch? A master batch is a color additive where a concentrated amount of colorant is processed into a polymer, that is a carrier. Now, the carrier is the polymer. Now, you have a polymer as well as a color additive. We have seen earlier colorant is an important additive with respect to modifying additives. So, therefore, this master batch is a combination of polymer plus color additive. This is a typical display of different types of master batches. In each batch you can have one polymer or two polymer plus additive. So, likewise polymer and colorants are mixed and then they are available in the pellet form. The carrier, which is the polymer, and the processing additives incorporated into the master batch are specifically designed to shoot a wide range of polymers. That is, these master batches are designed in such a way that is not applicable for thermoplastics alone. Whatever the type of polymer, the master batch should not impose any processing difficulties. Now, master batch is a clean and easily handled product in the sense that should not cause any environmental concerns. That is why it is available in a clean, easily handled product, and also it should disperse well in any processing machinery. These are the requirements, and this is how a master batch is prepared. Now, looking into the benefits, rather than going for every time a polymer and additive, we will look on the master batch is like a ready-made dress material which we can wear it readily. So, likewise the master batch will have polymer plus additives, colorants that will straight away we can use this master batch to prepare a product. These are the benefits. Now, this will ensure that there is optimum dispersion of pigments and additives, and then we have seen earlier what is meant by dispersion. A master batch will disperse very well in a processing machinery, and then you need not low stock holding compared to pre-compounded materials. If you want to prepare every time a polymer plus additive likewise, then you need to maintain a huge stock with a different type of materials. Now, the stock maintenance would also be low, and then dust free, no healthy or safety risk. These are all the environmental concerns. And then reduction in the purging cost. Once the process is over, the machine has to be purged out, that is whatever the color that is available inside the barrel, that has to be purged out completely for processing next type of material. So, there is a reduction in purging cost also. That is why people nowadays generally go for master batches. Now, there are a number of ways by which a master batch could be produced. There are mainly two main processes. One is a single stage process, other one is a two stage process. In a single stage process, all the components are combined in one processing step, that is polymer plus colorants all combined in one step, and then the process can be either pre-mix or split. That is, you can mix it at periodic interval, or you can split it into two, that is polymer on one side and colorant on another side. We will see how in with the diagram. Next, in the two stage process, single pigment are produced in the same manner as a single stage like this, followed by this in the second stage you have a single extrusion step that combines the required ratio of colorant and additive. So, that is how the two stage process differs from single stage process, as you could see from this diagram. This is an example for single stage master batch production, where you could see the feeding of the raw material here, Here you can have a split feed, or you can also have a pre-mix followed by a twin screw extruder that will actually pelletize. Now you have a master batch of pellets of a blue color like this. In a two-stage process, the first phase 1 is same, that is feeding of a colorant and a carrier which is a polymeric material is same, followed by a twin screw extruder is basically to prepare the master batch in the pellet form. Now you have pelletization of the single pigment coins rate. Now this will be feeded into another one where you have feeding. Now this will act as a feed. Now you have a single or a twin screw extruder, followed by again you can have in the form of strands, or you can have pellets. So this is a typical master batches that are available. The color you have different types of master batches, like color master batches which are available in standard colors. You could see these are the standard colors, and then customized colors and special effect. Sometimes you need fluorescent as well as pale looking colors, then black and white master batches. So these are additive master batches, where the master batches not only the colorant, the antioxidant or antistatic additive, processing aid, that is lubricant additive, UV stabilizer are all added and available in this form, and these are all dry color pigments. These are filler master batches, mainly the calcium carbonate to reduce the cost, and then these are all the special compounds where you have flame retardant additive as added as well. So these are the different types of master batches that are available commercially. Next we will move on to calendaring. What is in by calendaring mills? Calendaring is an important polymer processing operation which is used to convert thermoplastic materials into continuous sheets, films, and then not only to prepare sheets and films and also for applying plastic coatings to textiles and paper. Nowadays people do require garments that will prevent wetting of the garments. So a plastic finish is applied on surface of the textile. So then that is an example for plastic coating. When coating, the calendaring line is also called as a coating machine. Calendaring is an alternative to extrusion with the usual flame at 3 or more mils. Mils is a dimension with respect to thickness. A mill is typically 75 microns. For the production of sheet or film, plastic melt is compounded and pressed as it passes through the nips of a series of 3 or more heated, highly polished steel rolls. We will see that. A plastic bank is actually formed into a web in the nip between the first pair of rolls, and then passing through the second and the third nip will further reduce the thickness. A final thickness of the sheet is determined by the gap between the last pair of rolls called the gauging rolls. Finally, a take of rolls pulls the hot sheet around a chilled roll to cool the sheet or the film web. So this is a typical a scheme for a calendaring process. Now you could see a plastic bank is formed between the nip of these two rolls. So these are all stainless steel cylinder rolls available in different shapes. Now it will pass through a series of rollers like this, and each and every roll has specific functions. For example, these two rolls are called gauging rolls. That means this will reduce the thickness. Desired thickness of the film or the sheet is maintained by adjusting the gap between these two rolls. Finally, this is a chilled roll to ensure that this will be of at high heat energy. Now after passing through the chilled rolls, the heat energy will be reduced, and this is the final take off roll. Now the sheet is available for collection to the take off point. Now the origin of this calendaring process traces back to the rubber industry, where in olden days people used only two rolls, which is popularly called as two roll mills, a pair of rollers with a vertical nip between them. Two roll mill mixing started with rubber processing. Now it is available for various type functions, in the sense for not only for rubber, not for any polymeric materials. Nowadays one can go for two roll mill mixing. The polymer and additives are subjected to high shear in the nip, because as the two rolls rotate at a very high speeds, now you allow the polymeric material along with additives inside, then it is subjected to high shear. That is where the mixing takes place, as the rolls rotate in opposite directions. This is a typical example for a two roll mill. two rolls are rotating at opposite speeds, and then in between the rubbery material or the polymeric material are subject to high shear, and that is how the additives are mixed very well with the polymer. This is a typical example for a two roll mill used in the olden days, particularly in the rubber industry. Now, next we will move on to the equipment details of required for the calendering process. Now, the purpose for the calender is to provide sufficient energy to convert a mass of plastic into film or sheet without supplying so much heat as to cause degradation. That is, in a extruder or injection molding machine, the same thing happens. You feed the raw materials in the form of feeds, and then you maintain very high temperature, and then you convert it into a melt like form. The same way here, instead of melting it into a liquid, energy is required to convert this solid plastic into a film or sheet. We can obtain in the film or sheet because of the shearing action between the two rolls. At the same time, one has to maintain sufficient heat. Too much heat would result in degradation of the polymeric materials. This is how a typical commercial calendering equipment will be, where you have motors coupled with the gears and pulleys to rotate the rolls. So, in this example, there are three rolls aligned in the vertical fashion, and then the speed of the roll can be changed by controlling the speed of these motors. Now, next we will move on to the types of calendars. The way by which we align these rolls in a particular way will result in different types of calendars. Calendars vary in respect to the number of rolls and their arrangements. Examples of the layout of the rolls are the true L, that is L shaped roll, conventional inverted L, the same L in the inverted form, it will look like F, and a reverse fed inverted L, and then the direction at which whether it is fed at the top or at the bottom, and then the I type calendar and Z type calendar, and so on. We have different types of calendars. These large diameter heated rolls, these rolls will be heated as well to give heat to supply heat energy to the polymeric system to get converted from the solid form to the sheet form. Have the function to convert the high viscosity polylastic melt into film or sheet. I will look into one by one the type of calendar. This is a typical example for I type calendar, in the sense it looks like I. Here you can have as many as rolls possible. Now, in this example there are 4 rolls, normally 3 or 4 rolls are the most common one. Now, the plastic is allowed to flow in this direction. Now, you could see slowly its thickness reduces, and then it is available for further operations. This design was not ideal though, because at each nip there is an outward force that will tend to push the rollers away from the nip. Because of the high mechanical energy that is available at this one nip, another nip and another nip, at this the rolls would be subjected to some mechanical force try to de-align from this axis. So, that is one of the drawback of this I type calendar. Next one is the common one is this L type calendars. It looks like L. Here you have a 2 roll, and then the other rolls are arranged at 90 degrees to these 2 rolls, and then this is the way the polymeric melt will flow through. L type calendars have become popular because some of the rollers are at 90 degree to others, that is these 3 rollers are at 90 degrees to these 2 rolls, and their roll separating forces have less effect on subsequent rollers. That is the mechanical energy that is available at the different nips are well distributed. Now, L type calendars are often used for processing rigid vinyls like rigid polyvinyl chloride or rigid vinyl based polymeric systems. Next one is the inverted L or the F type. The F type is same as L type, but then mirrored vertically. Inverted it is also called inverted L. Inverted L type calendars are normally used for flexible vinyl based polymers. The flow pattern is like this. It starts from the top and then it goes like this. And then the most common one is the Z type. The Z type calendar places each pair of rollers at right angles to the next pair in the chain. These two will be at right angles to these two. So, likewise you can have as many as Z calendars possible. This means that Because of this 90-degree displacement between the subsecutive rolls, the roll separating forces that are on each roller individually will not affect any other rollers. That is, the effect will not be carried on. Calendars, in general, these are all the things with respect to calendar. That is, calendars with at least 4 to 6 rolls are used to fabricate thin rigid sheet, where the extra nips greatly improve the surface finish of the sheet. If you want to go for a very high surface finish, then 4 rolls will not be sufficient, then we go for extra 2 rolls to have that effect. The more popular are the 4 roll inverted L calendar and the Z calendar. Now, if you are looking into the advantages of the Z calendar, there will be less heat loss in the film or in the sheet, because the melts actually travel shorter distances, and also the construction of such machines are very simple, and they are simpler to construct because they need less compensation for roll bending. We will see what is meant by roll bending shortly. This compensation occurs because there are no more than 2 rolls in any vertical direction, as opposed to 3 rolls in a 4 roll inverted L type calendar. In a given place, you have only 2 rolls in the vertical direction, whereas in a I type or a L type you have 3 rolls in the vertical direction. So, therefore, in such rolls the compensation is required, whereas in Z calendar that is not required. Now, the speed of the calendaring rolls usually differs. As we have seen earlier in the equipment, controls are available to have the rolls to rotate at different speeds. They operate at different speeds to provide the best performance of the melt, particularly the required shearing action. Whether the high shearing action is required in the first pair of rolls or in second pair of rolls, accordingly one can vary the speed of the roll. In calendering, now we will see what is meant by roll bending. In calendering, the rollers are under great pressures, which can reach up to typically 40 or 41 megapascal in the final nip, that is in the last point where the sheets or films are sended to the takeoff points. The pressures are highest in the middle of the width of the roller, and due to this the roller gets deflected. Actually, the roller will not get deflect because it is a very solid stainless steel arrangement. What happens is the bending takes place with respect to either the film or the sheet. So, this deflection causes the sheet being made to be thicker in its center than it is at the side. So, as a result, because of this roll bending, the sheet will have the thickness will be more at the center compared to the edges of the rolls. So, there are 3 methods that have been developed to compensate for this bending. We will see one by one. They are roll crossing, roll bending and roll crowning. First, in the roll crossing. In the roll crossing, what will happen is the one roll is aligned at a particular angle with respect to the another roll. You could see the axis of this roll and the axis of this roll do not lie in the same line, rather there is a difference in the angle between these 2 axes. What happens if you have such an arrangement? With roll crossing, the rollers are put at a slight angle to each other, and because of this the force of the rollers on the melt is higher in the middle. Because of this arrangement, you could see at the edges the forces or shearing forces are less. At the center, where the impact of the full roller is with respect to the other roller, the force of the rollers on the melter is higher in the middle, where the rollers are on top of each other. Force of the rollers on the melt would be lower at the end. So, that is how we can compensate for that roll bending. And the next method is also called as roll bending. Here what will happen is roll bending involves applying movements to both the ends of the roller to counteract the forces in the melt on the roller. So, this arrow indicates the application of movement, that is a mechanical force is applied at this point in this direction, and at this point and at this point in the opposite direction, and that is how compensate for this roll bending. And then the next arrangement is by modifying the diameter of the roll itself, which is called roll crowning. Roll crowning uses a roller that has a bigger diameter in the center to compensate for the deflection of the roller. You could see this there is a slight deviation in the center. So, crowning like arrangement. So, therefore, the entire roll will not have uniform diameter, it will have a higher diameter at the center and a lower diameter at the edges. So, that is how also one can prevent roll bending. To summarize, in today's class we have discussed about the additives, particularly the examples for protective additives, anti-ozonant, lubricants likewise, and then we have discussed about master batch. What is my master batch? Master batch is a ready-madely available polymer with additive, and then we have seen one important processing operation, which is calendaring. What is meant by calendaring? In the calendaring, what are all the types of calendars that are available and a typical calendaring process. And if you look into the calendaring uses, there is a high surface finish, films and sheets are possible because of the roll arrangements. And not only the calendaring we prepare only films or sheets, calendaring is also used as operation is also used for coating various fabrics with thin layers of rubber or plastics, and also producing films or sheets from heat sensitive polymers. Some of the heat sensitive polymers could not be processed in the conventional processing machinery. There also we go for calendaring. After looking into this episode, these are the questions the viewers should try to answer. List some of the main types of protective additives currently used in the plastic industry. Identify and list out all these. What is meant by calendaring? State the advantages and disadvantages of the different types of calendar. Explain the methods adopted for the compensation of calendar roll bending. Thank you.